Hello, and thank you for coming to SIG School Scholars. Today, we'll be looking at linear functions. So, a linear function is, is a polynomial function that possesses either degree 1 or 0. So, the degree of a polynomial function refers to the exponent of the largest exponent of any variable term in the function. For example, we're looking at let's look at a general polynomial first. If we're going to look at the polynomial x to the third plus 2x squared plus x minus 12. This polynomial has degree 3. Reason being is that 3 is the highest exponent of any variable term. So, degree 0 would imply that the function f of x is equal to some constant, such as, let's say, c. If it had degree 1, however, that would mean that our function would be of a form looks like that. So, where a and c are just real numbers, and a is the coefficient. So this one has degree 1, and this one we say has degree 0 because we can write it like this. Like, we can write it so that c is the coefficient of that degree 0 term. And so because if we take anything to the 0 power we get 1, then it's equivalent to c. So, before we talk any more about linear functions, let's first discuss slope. So, what is slope? Slope is the average rate let's say it's just the rate of change of a function at a point. So, what does this mean? Well, what does this mean? Well, if we let's look at the example of a let's say a hill. Let's say that when we're ascending this hill, for every 30 meters we walk, we walk in the horizontal direction, our elevation increases by, say, 15 meters. So, the slope is the rate of change of the function. Well, one way we can define slope remember its meaning, we usually use the letter M to denote slope. We can remember it as rise over run. How quickly the function is changing, and by that we mean vertically, with respect to an increase in a horizontal position. So basically, a change in y over a change in x. So, for this hill, or whatever it is, we would take our change in y over our change in x. Our change in elevation over our change in horizontal distance. And what we get is 1/2. Basically, as we go over 1 meter horizontally, we increase our elevation by 1/2 meters. So, let's look at another. If we were to have, let's say, something that looks a little steeper. Let's say this is 15 still, but this is 20 meters. Well, on this hill or mountain or wherever, our change in y or change in x, rise over run, our slope, is change in y over change in x, which is 15 over 20, which simplifies to 3/4, which is larger than our slope on the previous in the previous example, because our elevation changes faster. We reach 15 meters faster than we would reach it on the other one, because we don't, well, the grade of the hill is greater. So, so for a line in the xy coordinate system, we can find the slope between 2 points on that line. So let's say this is some line, and this is a point x2, y2, and this is a point x1, y1. Well, this is run and rise, so rise, run, that way. The rise over run will be y2, oh man, it will be y2 minus y1 over x2 minus x1, rise over run. The change in y over change in x. So, okay. So, now that we've discussed slope, let's go ahead and look at some forms of linear functions. Okay. So, remember, a linear function is a polynomial of degree 0 or 1. So, the first form we're going to look at is called slope-intercept form. And this form is written as y equals mx plus b. So, the slope-intercept for a line, for a slope m and y-intercept b is y equals mx plus b. We discussed slope. Y-intercept is basically where the line intersects the x-axis, and therefore, the y-axis. Therefore, it's going to be what the value of the function is when x is 0, because it's going to intersect the y-axis when x is 0. So, we can substitute y. So y is equal to f of x. Okay. So f of x, we can also write like this: f of x equals mx plus b. So y is a function of x. So now let's do a little bit with this form. We're gonna first graph some lines written in y equals mx plus b form, and then find the y equals mx b form for some lines that are already graphed for us. So let's start with an example. Y equals 2x minus 3. So, to graph this line, we're going to, let's start with the point 0, the x value 0. So, when evaluated at 0, this function takes on the value negative 3. 0, and let's say this is where negative 3 is. Now, let's just go ahead and graph the value, let's say 2. So 2, we put 2 in here for our value of x. 2 times 2 is 4. 4 minus 3 is 1. So 2, 1. And this is what our line will look like. So, this is a line of slope 2 translated down 3 degrees. Shifted, I guess, is another word for it. The mathematical term would be translated. And translated down 3 units. And it has slope 2. So, linear functions are, hence their name, lines. They will graph straight lines. A polynomial of degree 0 or 1 will be a straight line. So, let's say other functions. Okay. Because they are lines, linear functions will have a constant slope throughout. And that slope is m, of course. Other classes of functions like quadratic, cubic, square root, those functions will have non-constant slopes. Okay. Rates of changes. The rates of changes will be different at different points. Okay. So now, let's look at this let's look at this a little longer. And we're going to look at x-intercepts and y-intercepts. So, y-intercepts, remember, of course, it's going to be negative 3 from the y equals mx plus b form. But y-intercept is when x is 0. So, we put f at 0 into our function. Put 0 into our function. What we get is negative 3. F at 0 equals negative 3. So our y-intercept is negative 3. And that's what we have graphed here. Now, x-intercept is going to be where the function intersects the x-axis. So, with that point, we'll have a y uh, value of 0. So on this graph, this is of course going to be our x-intercept. So let's say our okay, so what we're going to do is we're going to take 2x minus 3 and we're going to set it equal to 0. So we'll solve this equation, and what we'll get is x equals 3/2, and that will be the value of x at which y is 0, and therefore will be our x-intercept. So we can determine the graph of a linear function with just 2 points because its slope is constant. So we're going to look at one other case. So we're going to look at vertical lines and horizontal lines, the graphs, well, the functions for those. So a vertical line, of course, whoops, that's too big, that's too small, there, okay, that's good enough. Okay, so a vertical line, of course, looks like this. So okay, and a horizontal line will of course look like that. So a vertical line will cross through one x value, and it will have all y values. So a horizontal line will go through all x values but only exists at one y value. So that should be a clue in determining what their functions will look like. Horizontal line, because it has one y value for all x values, it's going to be a polynomial of degree 0. So if this were, let's say, 5, no wait, I mean, let's say this for the point 0, 5, and this were 1, 5, 2, 5, 3, 5, 4, 5, to infinity, and then to a negative infinity, then the graph of this function will be, I mean, the equation of this function will be y equals 5. For vertical line, what we'll have here, the equation for this line is going to be the of the form x equals b, the x-intercept. Well, let's not use b, let's use c, I guess. X equals some constant, and that constant is the x-intercept. So let's say that this one intersects, let's see, this point is, I don't know, 3, 0. Well, the graph of this function will be x equals 3. Okay. Now let's look at slope for both of these. For this one, let's say we're trying to find the slope between 2 points on this line. Let's say that 3, 0, as well as 3, negative 5. So, y2, let's say this is y2, minus y1 over x2 minus x1. And what do we get? We get an undefined answer. So, when we divide by 0, or I guess, when we okay, how about this? Let's say, When we take a number and divide by a number very close to 0, we get, let's say, for example, 0.01. Well, what do you get? You divide 5 by 0.01, we get 500, right? Well, let's go with this. Let's just say we have 1. Let's use 1. We divide by 1 by 0.01, we get 100, right? Divide 1 by 0.001, we get 1,000. Divide 1 by 0.0001, we get 10,000. So, as a number, and so you can see 0.01 is close to 0, 0.001 is even closer to 0, and 0.0001 is even closer than that to 0. So as we get closer and closer to 0, we can say that our division is going to increase very fast. Dividing by that number is going to increase. So we're going to say then that 5 divided by 0 is undefined. We can't divide by 0. But we can see that how this would make, dividing by 0 would give us, well, it would give us infinity, because that's where this is headed. If we just kept getting closer and closer and closer to 0, this number would just keep growing forever. So 5 divided by 0 is undefined, but it will, if we were to say that this denominator was close to 0, and we're saying it's getting closer and closer to 0, then it would equal infinity. And let's think about that for a second. So basically, saying that the rate of change from here to there is infinity. Well, think about how that would make sense. It's going to increase 5 units in 0. So rise over run. Its rise is 5, but its run is 0. It's increasing this distance in a infinitely small infinitely small run, I guess you could say. That's all we'll say on that, and let's go ahead and look at horizontal lines. So again here, that's 0, 5, and this one, let's say, is 3, 5. Now, the slope here, rate of change, take rise over run, and what do we get? 0. Rate of change here is 0. Basically because it'll take an infinite amount of time for it to go anywhere. Or it'll go anywhere, right? But it takes an infinite amount of time for it to increase vertically. Because it doesn't increase vertically, so the slope is 0. Okay. That's all we're going to say on that. And let's finish by looking at how to take a graphed line and turn it into, I guess, its equation form. Similar to how we did for vertical and horizontal lines, but for a more general, regular graph. Let's do it for this line. And then let's do it for this line, and we'll end with let's say that line. So this is the origin. This is the origin. This one, however, does not pass through the origin. Let's say that this point is -2, 0. And this point here is 3, 8. Those are the 2 points we have, and we need to find the y equals mx plus b form, the slope-intercept form for that one, and slope-intercept for this one, given that this is -2, 3, and this is 1, negative 2. And this is 0, 0, and 4, 4. So, first we're going to find the slope. y2 minus y1 over x2 minus x1. And we get 4 over 4, which is 1. So what we've got so far is y equals x. Now we need the y-intercept. And we see, we look at the graph, that it intersects the y-axis at 0. So there you go. The only x and y intercepts will be 0. So this is sort of the parent function, I guess you'd call it, for linear functions. It's unaltered. Its slope is the unit slope, meaning that it'll increase by 1 vertically as it increases by 1 horizontally, and it's not been shifted anywhere. So for this one, we're going to do the same thing. Follow our same procedure. 8 minus 0 divided by 3 plus 2. Get 8/5. So we'll write that as y equals 8/5 x plus b. So what we have is, let's say, we can use any point on this line, because this equation must satisfy every point on the line. So let's say 0 is equal to 8/5 times negative 2. So it's negative 16/5 plus b. So b, the y-intercept, equals 16/5. So y will equal 8/5 x plus 16/5. Now, our final one. Let's say m y2 negative 2 minus y1 over, again, x2 minus x1. That is negative 5 over 3. So, this means that our function is always decreasing, as you can see from its graph. As x increases, y decreases. So, let's go ahead and find the rest of our answer. So y will be negative 2, x will be 1, if we're going to use this point. So, negative 2 plus 5/3. Well, that's an improper fraction. Well, okay, that's an improper. That doesn't matter. We need to make these denominators alike. So we have negative 6 over 2. 6 over 3 plus 5 over 3 is equal to b, and b equals negative 1 over 3. Oh, wait, I made a large mistake. I'm sorry. Wait 1 second. So, this one only passed through the origin, so the b is 0. And our line is just going to be y equals negative 5/3 x. So, if we are going to use the, try to find b. Oh wait, this isn't right. I see what the problem is. Okay. This is because I made this problem up. The problem is that the way I drew it, it's supposed to pass through the origin. But if you solve the problem to find b, you see that b cannot be 0. So b ends up, if you solve it, being negative 1/3. And to solve it, I'll show you. You would do y is equal to, let's say, negative 5. Let's use the top one. negative 2 plus b equals 3. So b will equal 3 minus 10/3. And then let's say b 9/3 minus 10/3, you get negative 1/3. So that's our equation, really. Now, the reason why this didn't work out is just because I didn't draw it right. It can't possibly, a line with these 3 points could not exist. It's just not a straight line. I just drew it and made up these coordinates so that it would look straight. But this could not happen. And I see I guess one way you could see why it wouldn't happen is look at these points. The only way the line could be straight and pass through the origin would be if it has no y-intercept. That's not 0. So, I mean, like, it would have to be translated. It could not be translated, but this line would have to be. Basically, there has to be a common factor between that multiplies each x to get y in every point on this line. And you see the factor here must be negative 2, but the factor here is negative 3/2. So this line couldn't exist. If we made this 4, then that line would exist. And it would pass through the origin. But, oh yeah, and that common ratio there would be the slope, m. So the line would be of this form. Okay. So thank you for watching the video. If you want us to make a video on a specific topic, just leave a comment either in the comment section below or on our website at sigschooltutors.wordpress.com, and we'll try to fulfill your request as soon as possible. Thanks.